Computing technology is changing. Take cell phones, for example. How is it possible that the size of a cell phone hasn't changed much in 10 years, but the capabilities have changed dramatically? If we were able to take a cell phone apart and inspect the microchip inside, we would see that the building blocks of this microchip, which store bits of information and perform computing tasks, are much, much smaller than what they were 10 years ago. And there are many more of them packed in there. In fact, these building blocks, called transistors, are roughly 30 nanometers in size in today's devices. 30 nanometers is roughly the length that your fingernail grows in 30 seconds. These things are tiny. But get this, if we follow current trends to the year 2030, it's predicted that transistors will be on the size of single atoms, single particles. On this size scale, nature plays by a whole new set of rules, quantum mechanics. This makes it possible to take a new approach to computing and to strive for a whole new level of complexity and efficiency. For example, researchers predict that it'll be possible to search databases immensely faster. For my research, I'm studying quantum mechanical systems which rely on particles of light, photons, to perform quantum computing tasks. I'm designing microchips on which photons are the carriers of information. To construct a quantum computer, infrastructure is required to steer photons along desired paths and to slow them down or speed them up. My thesis involves engineering devices on the nanometer size scale which form part of this infrastructure. So, how can you steer a photon on a microchip? Turns out you can start with the same materials used in everyday computer chips, like IBM chips, which are based on silicon. We send photons down strips of silicon, which act like channels to guide the light. But how can you slow light down or speed light up? Nothing moves faster than the speed of light. Well, there's a catch. Light moves at different speeds in different media. So, if you can change the material in which the photon propagates, or change the environment that the photon sees, you can control how it moves in a material. My thesis involves developing new methods to dynamically change the environment that a photon sees in order to control it. Part of the challenge is to do this efficiently so that no photons accidentally escape from the system, taking with them the information that they carry. Who knows what computing technology will be capable of in year 2030 or year 2050? I think that quantum computing is the way of the future, and I hope that the devices that I engineer will form a small part of the next big thing. Thank you.